We import NumPy for numerical arrays, FastAPI components for the web framework, HTML response and Jinja 2 templates for rendering pages, Pydantic's base model for request body validation, and random forest classifier as our ML model to classify aerial targets from radar data. We initialize the FastAPI application with a descriptive title and configure Jinja 2 to serve HTML templates from the templates directory. We define training samples where each row contains 3 radar features: speed in km/h, altitude in meters, and radar cross-section in square meter, representing for distinct types of aerial objects across 3 examples each. These are the target classification labels for each training sample, for aerial object types repeated across 3 training examples each, teaching the model to distinguish between drones, jets, airliners, and birds based on their radar signatures. We initialize and immediately train a random forest classifier on our radar dataset in a single line, so it can classify incoming aerial targets from their speed, altitude, and radar cross-section. We define a Pydantic model that validates incoming JSON request bodies, ensuring the 3 radar metric fields, speed, altitude, and radar cross-section, are all present and typed as floats before the prediction runs. This async get route serves the dashboard homepage, rendering the index template with a custom page title passed as context. This async post route receives a validated target metrics JSON body and returns the AI classification result along with threat assessment and recommended action. We package the 3 radar inputs into a 2D list, run the classifier to get the target type, and extract the highest class probability as a percentage confidence score. We apply rule-based logic to assign a threat level, critical for fighter jets, elevated for drones, and none for civilian aircraft or birds, based on keywords in the predicted classification label. We map each threat level to an appropriate defensive action, full interception for critical threats, electronic countermeasures for elevated threats, and passive monitoring for non-threatening contacts. We return a JSON response containing the target classification label, formatted confidence percentage, assigned threat level, and the recommended defensive action for the operations team to act on. Now here is our index.html where I have designed the all-user interface. If you would like access to this code, just send me a message on our Discord server.